So I thought that I would do a series of videos on the C programming language that introduces it at a high level. I'm going to split the videos into topics of discussion, the first one being on just a general overview. And the next few videos will cover strings, conditional expressions, loops, functions, pointers, arrays, structs, unions, and maybe a few other things. C is a great programming language if you want to work closer with the machine. A couple of decades ago, C was considered a high-level programming language. Look at how times have changed. We've been babied with programming languages like Java, C#, JavaScript, PHP, Python, you name it. If you're familiar with cars and car repair, here's an analogy for you. You can pull a car using the frame machine, but we're going to do it with a hammer and chain. Why? Just to prove that we can. Now, of course, there are other reasons for studying C, the primary being the speed of the program. Understanding how everything works at a lower level makes learning other programming languages a breeze. I'm not going to get into the code, just theory. If you understand the theory, understanding the code will be easy. C is a compiled language, meaning that you need a C compiler to convert your readable code into machine code. Machine code is just a bunch of zeros and ones. C got its popularity mainly because Unix was written in C. Currently, most operating systems are written in C, as well as high graphics usage video games, and of course they use C++ too. Since C is a small language, most of the functions are defined in external libraries. That code is included at the top of the source file. The compiler copies the contents from the included file and pastes it into the source code where the include statement was entered. The most common one is the standard io.h header file, which stands for standard input/output. This library contains the code that's necessary for you to write data from and to the terminal. A couple of functions that you just can't live without are declared in the standard io.h file, which are scanf and printf. A few things to clear up before we continue. When compiling your code using, for example, GCC, you may have seen something like the following written: gcc sumfile.c-o sumfile. You're using the GCC utility to create an executable file called sumfile. You can enter gcc sumfile.c and it'll still work. However, this time it'll create an a.out file. To run it, you would have to enter ./a.out. If you do include the -o sumfile, you can run it by entering ./sumfile into your terminal. Also, the order matters slightly. You have to enter the name of the executable after the -o attribute. You can, however, move the -o to the beginning, such as gcc-o some new file sumfile.c. Also, the executable files and source code files names don't have to match. The -o means output, so it specifies the output file. The -o stated previously is different from utilizing the capital O as in -big O, -big O2, -O3, and -o fast. The capital O is set when you want the GCC to optimize your code. -O3 will include all the checks of -o and -o2. Maximum optimization is done with -o fast, but will also take the longest to compile. GCC optimization is switched off by default because it takes longer to compile the code. If you're writing a C program and you want to use the command line option, like the -o option, you'll have to read it with the get_opt function. First, include the unistandard.h header file. Unistandard.h is not part of the standard C library, but is instead part of the POSIX library. To read each of the command line options, place the get_opt function into a while loop. The last argument provided to the get_opt function states that both the and O are command line options, that the O option also needs a command line argument, and that that argument will be included immediately after the -o option. To get the command line argument, you'll use opt_arg variable once the O command line option is matched. Your command line options can also be combined as long as the option that requires an argument is written last. If you want to include both command line options and negative numbers, you can split the main arguments using the dash symbol. You're probably wondering why we must use the period / before the file name. If you were to enter some file without the period / the operating system would try to find the file in a directory specified in its environmental path variable. If it's not there, it'll let you know that the file doesn't exist. To get around that, you're telling the terminal to look in the current directory to execute the file. dot forward slash specifies the current directory. If you really want to eliminate the dot forward slash, you can copy the folder's absolute path that contains your source file and append it to the environmental path variable. And one last thing, if you're using GCC on a Linux distribution, the compiler will have created a file named subfile executing the command line gcc subfile.c-o subfile. On Windows, the name of the file will have a .exe appended to it. So I think this is it for this video. I'll see you guys in the next one when I cover strings.